Okay, here we go. This is the last piece of chapter 5. So, thanks to the corona scare and quarantine, whatever you want to call it, the apocalypse, I've managed to make some videos of chapter 5 and we're almost done. So this is long division of radical expressions. Now, when we're thinking long division, I'm really hoping you know what long division is. I know some people have gotten through school without it nowadays. I'm old enough to know that it was just something that we were expected to know early on and use throughout our lives. Long division, for a refresher, you just take this number into this number. It goes in twice, gives me 4. 2 times 2 is 4. Then it would leave me with 6. 2 times what is 6? 3. That would give me 6. And I'd have a remainder of 0. I know 2 goes into 43. 23 times, or 46, 23 times. We're going to use that thought process. This is divided. So what we can do, this happens when, if you notice, 2x squared minus 7x plus 9, if something doesn't factor out nicely, then we have to use this idea of long division. If we get some quick, easy factors, then we go ahead and factor it out. But when we are talking long division, with radical expressions. Hopefully I wrote everything. I think that's example 6. Yeah, example 6. What we want to do is focus on this number first and this term. Those two terms are all we care about. I don't care about that stuff, and I don't care about that negative 2. Whatever multiplies through will fall into place. But what I need to do is I need to make x equal to x squared. That's my goal. I need to make this equal this. Now our signs are going to stay the same up here, and we're going to subtract down here. So think same sign up here, and then subtract down here. So how do I make x equal to x squared? That's the key thought process right here. It's all I care about. I don't care about that negative 2. I don't care about that piece. So I make x equal a 2x squared by multiplying by x. That gives me 2x. And x would give me my x squared. When I do that, I come down here and I subtract it. So we do the opposite down here. Subtract it. What I'm doing here is I said, okay, I need to multiply x by 2x to get 2x squared. What I essentially am doing then is multiplying my whole quantity. X minus 2 times that 2x. That gave me my 2x squared, but then I also have a negative 4x. So my negative 4x, again opposite, think opposite down here. I have a negative 4x, I'm going to subtract it. Minus a minus, minus a negative. So we're adding it. 4x. That 9 is just along for the ride. There's a 0 here. I don't do anything there. So I had an x minus 2 times 2x. Remember, I got this 2x because I needed to make x equal 2x squared. Once I figure that out, I multiply through whatever they give me here. I multiply through. My 2x squared goes away. I have a difference of negative 3x, and I bring my 9 down. So now I have to say, I need that to be the same. I need to make it equal that so it'll go away because I'm going to subtract. So that's a negative. I need a negative up here. 3x's, I have 1, so I need to multiply by 3. Again, when I do, I'm actually taking my x minus 2 times 3. That gives me the 3, well I should say negative. That gives me my negative 3x that I need plus 6. I'm doing the opposite because I'm going to subtract. So because I'm subtracting, I change the signs. So when I write it here, it's going to be 3x minus 6. So I have x times negative 3 is negative 3x. Subtract it is positive 3x. Negative 2 times negative 3 is positive 6x. Subtract it is negative 6. I end up with 3. Now what happens here is I'm to the end. I can't do anything else. I have 3. I can't make x equal 3. So what I do is I write that I have 3 left over out of x minus 2. So my answer is 2x minus 3 plus 3 over x minus 2. Sometimes we'll get down to where we have an x minus 2, it divides evenly and we're done. In this case we don't. Now the other, well, I don't want to go that far yet, let me wait. So let's do another example. Now remember, this is only for something that doesn't factor out cleanly. 2x squared minus 7x plus 9. I can't factor it out cleanly. If I could, I would, and I'd just take an x minus 2 out. But this is what I'm left with. The reason I'm adding is because I end up with a positive 3. Remember, up here, we always work with what the sign is here. We want it the same because we're going to subtract to make it opposite. So we'd add and say, well, I can't do anything. I can't make x equal 3. So that's when we just write, well, it's 3 over x minus 2. So if I write it up there, it might make a little more sense to you. Okay. I'll write another one down here. Example 8. I'll erase the rest of that in a minute if you're still running it through in your noggin. X squared minus 6xy minus 7y squared. That's all over x plus y. So again, now I'll erase the rest of it. What I'm going to do is I'm going to think x plus y goes into x squared minus 6xy minus 7y squared. Again, my only main focus is this one and each term. How do I make x equal x squared? I have to multiply it by x. When I multiply it by a positive x, I get positive x squared, and I subtract it. Well, then I have a y times an x. I have positive xy, so I'm going to subtract that as well. When I do, I combine these, and I have negative 7xy minus 7y squared. So I come up here, it's a negative, so I need it to remain the same. And I say, how do I make x equal 7xy? I already got my negative. How do I make it equal 7xy? Well, I multiply by what's missing, 7y. So I'm going to multiply by 7y. When I do, I get my negative 7xy. X times negative 7y is negative 7xy, and I'm going to subtract it. So I write the opposite. Now I'm multiplying y times a negative 7y, which gives me a negative 7y squared, and I want to do the opposite. When I do, I see that this is a case where my remainder is 0. I have nothing left. It went in evenly. There's my answer. What this means is that this can factor out. My x plus y is one factor because they said, how many times does it go? Well, it goes x plus y. That's a factor. And then x minus 7y is a factor. And then I can work that out. If I work that out, I would get x squared minus 7xy plus xy minus 7y squared. I combine those and get negative 6xy, and that proves that it works. There's my answer. So I got a nice clean factor, but it's because they gave me one. This is a factor of it. Okay, let's do one more. And again, like I mentioned at the beginning, with long division, it's one real concept to think of. Make this equal that. Once you do, you multiply through. Then make this equal that. How do I do that? Multiply through, and then so on and so forth. You just keep going with that thought process. So that first term is the biggie that you're worried about. The first term, and then the first term of your answer. Okay, one more. Let's do example 9. example 9, I might not have written it out or they just gave it to us, but we are taking x plus 2 into x cubed into x cubed plus 9x squared plus 26, this is a doozy, x plus 24. Now, again, if you ever need to, sometimes they might leave one out. Let's say they left the x squared out. You could put an x squared, a 0x squared in. If any of them are missing when they give them to you as a problem, let's say they had x cubed plus 26x plus 24, we would add a 0x squared to hold our place, because that's what we're going to end up getting when we go through here. We're basically multiplying by one less, if you notice that. The key is, I need to make x equal x cubed. So I multiply by an x squared. When I do, I get a positive x cubed, I subtract it. Here I get a positive 2x squared, so I subtract it. So now I have 7x squared plus 26x plus 24. Doesn't matter how many they give me, I just drop them down. As long as nothing's here, I drop it right down. It's like saying plus 0 plus 0 plus 0 or minus 0, however you want to think about it. Now I need to make the x equal 7x squared. So I need a positive, because that's positive, and I'm going to do the opposite because I'm subtracting. So a positive, well, I need to multiply by 7 to get my 7. To make x equal x squared, I need another x. So positive 7x gives me positive 7x squared. And I do the opposite because I subtract. Positive 14x. So I do the opposite because I'm subtracting. So now I have 12x plus 24. Again, this one, it's all I care about. I need to make this one equal that. Then I need to make this one equal that. Now I need to make this one equal that. That's the main process to follow here. So I need to make x equal 12x. So I multiply by 12. That gives me 12x. I subtract it. It gives me a positive 24. I subtract that. Perfect. 0. We like 0 as a remainder. Then we don't have to write anything else. Then we look at it up here as this piece. Depends on what they're asking for. But this is our answer for the long division. However, if we look at that piece, I'll just go up here. We'll go that way. If we look at this piece, we can see, we always want to try to factor out. You see that you have an x squared and a 12 and a 7. Well, it just so happens that x plus 4 times x plus 3 is x squared plus 7x plus 12. There's my positive 12, there's a plus 3, plus 4 is my plus 7. So how we would write the actual answer is we take first our x plus 2, then we multiply, I'm going to just go in order because I want to. We say, well, it's x plus 2 times this piece. Well, this piece is x plus 4, x plus 3. So I can say it's x plus 2 times x plus 3 times x plus 4. There's my factored answer of that piece. There it is. This huge, nasty, icky chunk factored out is just that. Pretty slick right there. Looks nice there. Looks naughty there. Nice, naughty. Alright, so that's long division. Hope you liked that. I did. It was pretty fun. So now I guess we're probably on to chapter 6. It all depends on how long they make us stay off of campus. So hopefully I can see you before May. We'll see. Hope all is well.